Alright guys, we're back here to review the Math 8 Chapter 2 Mastery. Again, the reason that I'm posting these videos up on YouTube and I'm not concerned about it is I make new tests every single year. Even if they're similar to the old one, you're not going to be able to just come and watch a video and assume that my test is going to be the same. So if it's 2021 and you're one of my Math 8 students now, this is not going to be your test, right? And hopefully 2021 has been a bit better than 2020. But here we go, diving into Chapter 2. If you're watching this, you probably need to go do the assignment in Schoology. So please watch this and then go complete that assignment and make sure that you submit it. Don't just do it. Make sure that you submit it. So number 1 and number 2, we're talking about 3 consecutive numbers, which means one after the other one, except for in number 1, it is 3 consecutive integers straight up. And number 2, it's 3 consecutive odd numbers. So even though they're odd numbers, the gaps between those numbers will be 2 and then 2 more, which will give it 4 from the original. This often confuses people why the last one is plus an extra number, because you can't just say x plus 1 again, because then you'd be repeating the same number. So if we reference our lowest number, add 1 to get to the next number, and from the lowest number, add 2 to get to the next number. We create a single variable equation here, well, this side's an expression, but then we make it an equation, solve it for x, and that tells us our lowest side. So we know all 3 of them. Same thing with our odd numbers, except then we have the plus 2 and the plus 4, so we actually have 3x plus 6. We solve out that math. Again, if you need to see that or need help with it, please come to Math Lab and actually get some help from me. I'm not walking through every single step in this test or in this video. And number 3, same situation, except now instead of like being consecutive numbers, we know that the middle side of the triangle is 9 times the length of the shortest side, and the longer side is 1 more than that. And I guess we're dealing in inches here. I don't know why I didn't make that centimeters. I really do like the metric system better. So we add up all of our x's, we add up our only constant, or we grab our only constant, take it with us, subtract that from both sides, divide by 19, get that x is 2, plug it in, solve our other sides from there. Michaela, actually the last Michaela that I had was very bright, would not have made this mistake. So this was just a name that, I pulled out of a hat. Michaela made a mistake here. What should she have done? Well, with the -4, trying to get rid of a -4, she should have added 4, or you can say take away a -4, which is the same as addition. In number 5, in solve for x, we can't. Right, we create here what we call a mathematical disagreement, or like a non-truth. So this, I should actually say that's not equal. So there is no value of x that will make this true, because 2x minus 5 and 2x plus 7 cannot be equal. Think about it, 2x and 2x are the same value. So can a value minus 5 be a value plus 7? I often talk about like time travel. Can you take your age right now, subtract 5 years from it, and make that equal to your age 7 years from now? Well, not unless like you can split your body, clone yourself, go multiple places in time at once. Like that can't happen. In number 6, we distribute first. We use that distributive property. The other option would have been to add 5 first and then divide by 3 on both sides, which actually would have worked here. So there is another option to how we solve this. There are always options, right? There's a lot of right ways to get to Florida. So if we add 5, we'd get 21, then divide by 3, we'd get 7. So x plus 6 would equal 7. That would also equal 1. But if you take the route that I have shown here and do the distributive property, we get 3x plus 18. Make sure that you get that multiplication of the 3 times 6. That's a mistake people like to make. That becomes 3x plus 13 equals 16. We take 13 away from both sides, then we divide by 3 and get x is 1. In 7 here, again, I didn't show my work because this is my answer key. I add 10 to both sides, getting to -2. I then divide by 2 to get to just 1x, and I get that x is -1. In part B, we're going to use reciprocal multiplication to deal with a rational coefficient. Right? That's a fancy way to say I'm multiplying by a fraction. Right? A rational coefficient means multiplying by a fraction. If we multiply a fraction by its coefficient, it becomes 1. So we just get 1x. Again, we don't need to write the 1. 30 times 3 going across the numerator gives me 90. 1 times 2 gives me 2. So that reduces out to 45. Moving on to the back, I'm doing a pretty good job of keeping these things under 10 minutes. I'm shooting for that because I also need to get on Zoom with some of you guys in 10 minutes. Or sorry, in 5 minutes actually. Back here, same situation. We're going to use reciprocal multiplication. I didn't write my workout very well at all, but 4 would get multiplied by 7 over 2, which becomes 14 over 2. Sorry, tripping up on my words here. 7 times 4 would not become 14. That would be 28. So another way that we can show this is what number can be plugged in to multiply with 2 sevenths. So you can't really see my 2 there. But what we need, if we have 7 in the denominators, we need a 28 in the numerator to equal 4. So x needs to be 14 so that when we do that multiplication across, it becomes 28 over 7, which will reduce out to 4. The other way we can do this is reciprocal multiplication, like I started saying wrong numbers for before. We would multiply by 7 halves on both sides. 4 times 7 would be 28 over 2, and that would give us our 14 as an answer. So not this 28 over 7 that I was referencing, but we would still get 28 on top in the other work as well. Again, come to Math Lab if you want to talk about things. I'm not writing stuff out, which might make this a little complicated. Here we would subtract 2 from both sides, getting 2 on the right side. Then we would multiply by 3 to get to just 1x, and that gives us 6. And 9, as you can see, I multiply both sides by 5 to get rid of the division by 5. That's how we get to 3x minus 9. Of course, that makes my right side 30. I add 9 to both sides, resulting in 3x equals 39, and we get 13. Aquatown and Wet World, we've got our equations here with the initial entrance fee plus how much it costs per ride. Entrance fee per ride. So when do we make if we make the parks equal, how many rides would that be? 4, and that would be $7.50 at each place. Pretty cheap, if you ask me. Mertz and Mavis. Yes, this is kind of a wink or a nod at car companies that actually exist. But we have our base fee per day, 15 cents per mile. One thing I need to go back and rewrite for this problem is this is just for a 1-day rental, right? So some of you guys wrote about, well, it depends on how many days we're renting. We are not going to put a variable attached to our days because we're just going to talk about a 1-day rental. So where they would be equal, if we set the two equations equal to each other, would be at 50 miles. They would have both cost $42.50. So Mavis, if you're staying close and going for a short trip, or Mertz would be the better choice if you're going on a long trip or a trip over 50 miles. And in 12, you should be able to understand what I mean by this or come work with me in AO or extensions. So because I need to get on Zoom with some of you, I'm going to stop my video here. But if you want to come see me about no solutions, one solutions, or infinitely many solutions, you've got 3 times throughout every day to do that. Math Lab, AO, and extensions. Oh yeah, math class. So you got 4. Sweet. Keep your questions coming. Thank you guys for your hard work. Go to Schoology, get the Progressing to Mastery done. Keep up with your Khan Academy work. We'll be back in person eventually.